Hello, good evening, friend. Today I am going to explain the next problem, next example of the ncert chemistry p block elements of grade 12. Let's see what are the problem. First one 7.15. Although electron gain enthalpy of fluorine is less negative compared to chlorine, but fluorine is stronger oxidizing agent than chlorine. Okay, so come when you go, that is the you know electron gain enthalpy, electron gain enthalpy gain enthalpy electron gain enthalpy of fluorine is saying less negative, you know less negative than chlorine, less negative than chlorine. Reason why reason why due to small size. Okay, due to small size. Now, another things which we have to understand, which we need to understand, and we need to understand that they are saying, but chlorine is stronger oxidizing agent than chlorine. Now, oxidizing agent when you are going to explain, that is oxidizing agent. Okay, so oxidizing agent, agent oxidizing agent, in bracket I am writing standard 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 oxidation potential, oxidation potential standard oxidation potential. This standard oxidation potential is depending on not the only electron gain enthalpy, depends on, I am writing standard oxidation potential depends on first one, electron gain enthalpy, electron gain enthalpy. Second one, second one when you are going, that is hydration enthalpy, hydration enthalpy, hydration enthalpy. And when you are going for the next one, that is the third one is sublimation enthalpy, sublimation enthalpy, sublimation enthalpy. And fourth one, bond dissociation enthalpy, bond dissociation enthalpy. Okay, bond dissociation enthalpy. And next one is lattice enthalpy, lattice enthalpy. So there are several factors which determine the standard oxidation potential. Right, now what we have to understand here, in case of fluorine, because of smaller size it is having highly hydration enthalpy, and because of the small size they have the low bond dissociation enthalpy. Due to these two factors, the fluorine is stronger oxidizing agent compared to chlorine. So let us see our answer here. Solution. Okay, due to higher hydration enthalpy, due to higher hydration enthalpy and low bond dissociation enthalpy, low bond dissociation enthalpy, fluorine is stronger, fluorine is stronger oxidizing agent than chlorine. Okay, now to understand this little more useful way, what we can do, that when you see this one, two factor, bond dissociation enthalpy and hydration enthalpy. So how the hydration enthalpy, when you are going hydration enthalpy, hydration enthalpy, high hydration enthalpy, what is meaning of, when you are dissolving in the water. Okay, so fluorine is having a small size, what will happen, it will be surrounded with the so many water molecule, so it will be easily hydrated. Okay, here you can see. That is why compared to chlorine, it is a large size, less number of water molecule will absorb. And second is there low bond dissociation enthalpy. No, low bond dissociation enthalpy. Dissociation enthalpy. Then low bond dissociation enthalpy. What is meaning of this? Why? That if you see fluorine and fluorine, okay, so fluorine that is single bond is there, and there is the three lone pair electrons are there with the fluorine. So what will happen? This is small size. There will be the interelectronic repulsion. Interelectronic repulsion. Interelectronic repulsion. Now if interelectronic repulsion will be there, so they will they will force to keep apart. Due to this, what will happen? Due to this, the bond will become weak. The bond will become weak. Will become weak. What will happen if the bond will become weak? Means you will supply little amount of energy, so this will get broken like this. So this is the two factor. The fluorine is stronger oxidizing agent. First one is the high hydration enthalpy, and second one is low bond dissociation enthalpy. Now let us move on another question. Fluorine exhibit only -1 oxidation state, whereas other halogen exhibits -1, +1, +3, +5, and +7 oxidation state. This is very patent, question, and very easy also to understand this. Let us see how can we answer this one. Solution. If you see fluorine is, this is the this is the fluorine where you are most electronegative atom, most electronegative atom, that is tendency to attract shared paired electron. So most electronegative atom, as it is the most electronegative atom, so it will not be able to remove the electron. Okay, most electronegative atom, so it is difficult to remove the electron, and hence do not show positive oxidation state. Okay, oxidation states, and also lacks d orbital. So it's not possible to expand the oxidation states. Now see, for while other halogen atoms like Cl, Br, I, they have vacant d orbital, so that they can expand their +1, +3, +5, +7 oxidation states. For example, if you see IF7 is there, so which one is most electronegative? That is fluorine. So if you consider this is X, +7 in bracket -1, fluorine equal to 0. So what will happen? X minus 7 equal to 0. So X is equal to +7. Okay, this is. Now next one, BRF5. If see BRF5, what will happen if it is X So this is 5 in bracket minus 1 fluorine, that is 0. So x minus 5 equal to 0. So x is equal to plus 5. Okay, this is, if you go another, suppose ClF3 is there. So this is x plus 3 in bracket minus 1 equal to 0. So x minus 3 equal to 0. So x is equal to plus 3. So it is, next one is, suppose is there ClF. Okay, so this is x in plus in bracket one atom is there, so minus 1 equal to 0. So x minus 1 equal to 0. So x is equal to plus 1. So they are capable to give the positive oxidation state. They are capable to give the positive oxidation state as they are having the vacant d orbital. Okay, so these atoms can explain, that is plus 1, plus 3, plus 5 and plus 7 oxidation state. Okay, I explain oxidation states. I explain with example also. You will be able to understand why fluorine gives only negative oxidation state, because it is most electronegative atom of the all the known elements. Okay, so that it will not be expand its positive oxidation state. Why not plus 3, plus 5, plus 7? Because it does not have the d orbital. Now in case of chlorine, bromine, iodine, they are not small size, they are not most electronegative atom, so they can represent the positive oxidation state in the interhalogen compounds, and they can exhibit plus 1, plus 3, plus 5, plus 7 oxidation state, which I explain in the example. Thank you so much for watching, friend.